y'all. Darley Berry Jr. here back for some more physics. Midway through a problem, I'll go ahead and finish solving. It's basically solving a derivative. It's basically what it is. A rather complex derivative, potentially. I'm doing the problem a different way than I did before. Actually, we can use just a single window. And let me change my scroll screen. Scattering. It was found out the impact parameter, which I understand now to be the perpendicular distance between the incident particle velocity and the center of force that's causing the particle to scatter. And now what I need to do is plug the impact parameter into equation 3.93, which will give us let me utilize the proper word. What's the word of this thing again? I don't remember exactly the exact terminology. Cross cross section cross section angle. What is sigma big theta? And theta is the complete or total angle of diffraction. So it diffracts one time here, then it diffracts a second time here. We add those two together, you get 2 gamma, and we call that whole angle big theta. So if I remember right, it's something like the cross-sectional area, but I could look up okay, scroll here. Differential cross-section. So the differential cross-section is what we need to get by plugging in for this equation here. So what I'll do is start first with this. I solved for S earlier. So it does seem pretty complicated. But I'll simplify this a bit. We have this. I need to take the derivative of this. So it'll be basically the derivative of the first term plus the derivative of the second term. This derivative is much easier than the way I did it. So I was able to do it a different way, but the derivative was extremely hard. Like I said, I clearly won't come out with the same answer, at least the same form of the answer. It might not even be worth trying to see if it's the same answer. So let's go ahead and work this out. So we have an cosine theta over 2, 1/2, 1 plus n squared minus 2n cosine theta over 2, negative 1/2, plus an sine theta over 2, negative 1/2, 1 plus n squared 2n cosine theta over 2, negative 3 over 2, uh, 2n sine theta over 2, and 1 over 2. And then we have 2 cosine theta over 2, 1 n squared minus 2n cosine theta theta over 2, negative 1/2, should still be a plus that is a negative already. Then it cosine becomes negative, so that's positive. That's right. So negative here from that derivative. So it is negative. And then we have half. Since these two will cancel out, find that's a common pattern. Have a n squared sine squared theta over 2, 1 plus n squared minus 2 n sine theta over 2, negative 3 over 2. And I multiplied that in earlier. Seems like that's it for that problem. Looking at my class notes, uh, professor's answer is a lot simpler. Oh, I forgot I have to plug it into the first thing. Oops, I got that part. So we have theta, sigma of theta equals s over sine theta ds over d theta. So that equals, so we have s, which is this, all of that is going to be divided by sine theta. Then we have to multiply by all of that, which is everything on the second line here. Mhm. So multiply by this, we have this, and I'll probably, right. So here's an easier way to simplify this, and this is a subtraction. I have to keep that in mind. It's ugly, but I mean, it is the answer technically. It's not simplified at all. Should I try to simplify it? I will say no. Let us leave the answer like this. Got the differential cross section, got an expression for the parameter. So all I need to work on now is the first problem, which is which I'm not really sure how to do. I'll ask about that on Monday. I was able to do problem 2, which was a very cool problem. It is from the textbook, and we just looked at the third problem, so I need to work on the first problem still. But I'll look at that. So perhaps what I'll do is take a look at the either take a look at the foundations homework or make it a short one today or do both. So What I'll do, I'll just short one, do a quick derivative. I'll take a quick break and either come back later to do some foundations homework or come back tomorrow. So we'll see. So like, subscribe if you haven't. Make a note on the uh, post page on my channel if you have a preference. And I'll see you next time.